Welcome, everyone. I'm happy to see all of you here. It's really great to have you. And I'm excited to know that you all care about the performance, not about the Git, not about the animation, but here. I'm really glad about that one, because that was a competition between our friends. Let's get started. Today I'm going to talk about performance topic, how to unblock a main thread and get smooth replication. I'm Sinan Kozak. I'm an Android developer. I work in the field for more than 12 years. I wrote a book 10 years ago, and I'm planning to do a small retro about that one. I don't know, I had one chapter, but that chapter was about performance. So 10 years ago, I started learning about performance and runtimes and specific things, and shared my knowledge with the Turkish community back in time. Now, at the end of this presentation, I'm going to try to do a retro, what has changed, what didn't. Besides that, I work at Delivery Hero as a staff Android developer. You might ask, what is Delivery Hero? If you live in Berlin, you might know, but if you live in different parts of the world, you might recognize the other brands that we operate. We have 70 other brands, and all of them are using, we operate in 70 different countries, and all of those countries, we use the same rider application, which I work at. And the performance of those applications are very important, because there are thousands of different devices, and our riders are using multiple devices, specifically as a backup. And most of the time when they have a device, they prefer to buy a cheap one over a most luxurious, most powerful version. So it means our user base has really nice retention of coming back to our application. They work with us, but most of the time the device they choose is really not great. So we need to make sure that our operations are smooth, our application is working well in any case. But this is how they use it. This is an internal video that we got from one of the writers, and the expectations of our application is really high because they earn money with our application and we earn money with our application as well. But the thing is, they will have to learn where they need to get their order and deliver your food when the people like your order. But there are different stages of the slowness. Not all of the slowness are the same. Some of them could be just sluggish, UI elements, animations, and some of them, not coming from me, some of them just freeze your application and block user input altogether. But let's look at what kind of things. Important point is application tries to render as much as they can. 1 second. Is music coming from me or you? Yeah. Okay, you have to bear the music, so I'm sorry about it. There are different stages of rendering, slowness and junk. One of them is slow rendering. That happens when rendering takes more than 16 milliseconds to the 700 milliseconds. This will show itself as slow animations, a sluggish application, but it's probably not going to affect the usability of your app. But the one that could affect is frozen frame. If you notice a black screen before after clicking a button. If you notice a not rendering application when you started, it is because they have a frozen frame. And that happens after 700 milliseconds. That means the application is not able to render a single pixel on the screen, and users are not able to see anything, and that's called frozen frame. But the most and infamous one, the application not responding. If your main thread takes more than 5 seconds to do an operation, and there are other certain conditions that applies, application become unresponsive state. And if it is visible to user, operating system specifically ask user if I can close this application, or would you like to really patiently wait for this app to finish what they are doing. If you know what you're doing, like exporting a picture, maybe it's acceptable to wait, but in general, it's unacceptable for most of the users. And as we know that apps has limited resources. Why? Because we are running on different devices that we do not control. Probably none of the software profession has this much of variety of the device that we have. That's why we need to create optimized application. We always talk about how iOS applications are optimized. It is much easier to optimize for certain device type when you know where your application is going to run. But on the other hand, we have thousands of devices. You don't know the age of the device. You don't know how fast their RAM is. You don't know how good their CPU are. And if I need to give an example, we are trying to solve. At the moment, we are supporting 9 years old devices at our company for our riders, because we know they still use it, they still deliver for those devices. So we would like to be welcoming as much as possible those use cases. But if we compare the performance, it is like 10 times slower on those devices, and it's really difficult to optimize without doing any compromises. So if you look at what the frozen frame looks like, or what the slow rendering looks like, when you do the profiling, it will look like this. The red one indicates that application tried to render something, but the main thread didn't finish the job, so it just was, application wasn't able to render whatever. But this is also what it looks like when it's acceptable. All of them are yellow. That means there was some sort of slowness. It could be animation, it could be something else, but there was not a single frame drop. This is an acceptable case. We are not aiming to have a perfect application that runs on all of the devices smoothly. We need to find balance for our trade-offs where we can have good and bad things. And in this talk, I'm going to show you the things that work for us. But on the way, while we are doing those experiments, we also figured that we need to do some trade-offs. Some trade-offs like change the application size, our application size increased in terms of having a good performance, and some of them were like we got faster application startup time, but we had to show a loading dialog to riders. You might ask, why do I care about it? But I can say that when you have a slow application, there will be crashes, because users will press the buttons in a way that you will never imagine in the testing environment. As I showed you the video, we never experienced that as the rider is doing that many full to refresh. We actually had a discussion about it, and everyone considered that that was a tracking mistake. But it turned out it wasn't. So always get prepared to what your application can handle. And one other famous case is if you like to show a foreground service, those things have restrictions. It needs to start showing the notification under 5 seconds. And if it doesn't, application crashes. Operating system thinks that you are doing something illegal without showing to your user. In this case, the main thread needs to be free so your service can start. And there are many more cases like this for the broadcast, for the intents, and for foreground services. We need to create environments so our application can work. Well, you might ask, is there a magic solution? I believe you are here for the magic solution. I would say maybe, but it's our responsibility to apply different suggestions and do the profiling. There are different categories of solutions. One of them is, and probably the first and most important one of them, creating space for your application to start. If you have memory inefficiencies, your application will struggle to allocate new memories. There will be multiple garbage collection invocation that might pause the runtime. An application eventually might get out of memory issues. But until getting the out of memory issues, we figured out cases happen when application is under pressure. Our application is being used 8 hours average per day. So that means during that day, any memory leak could affect a rider's experience or a user experience throughout the day. Another one is rendering the first frame. Like, if you don't want to show a frozen frame, if you don't want to show a bad user experience, we always should be able to show something meaningful to the users. And there are a couple of things that prevents that one when you have a big application. And most importantly is keeping the main thread empty as much as possible, doing operation efficiently as possible. And if you have a long-running operations, move them to execute in the background threads. I will go to details on those things. When you do loss of allocation for caching or operations, JSON parsing, or bitmap operation, you always use some sort of memory, some part of the memory. And applications have limited resources based on the devices. Some devices could have 1 GB, 2 GB RAM, and some could have 12 GB. But in the end, runtime will allocate you, Android runtime will allocate you limited amount over that possible RAM. So we need to be concise about what we are doing. And if we don't, garbage collection will kick in more than it's necessary, and it will look like this. In this particular example, garbage collection is trying to clean up the memory as much as it can, But the blue part is the Java code, Java heap, means that our code keep holding reference of the objects that we are creating. The rest of the things like graphic layer and the native layer doesn't change that much. Apparently there's no leak, but in this case, Java layer keeps holding it. And when you do profiling, if you see something like that, that means there's 100%, you can be 100% sure that there's a problem, there's a restriction, and even if you have the most efficient code in the world, the garbage collection will kick in and the runtime will not allow your application to run. So best thing you can do, if you know that you have leaks, fix them. And the memory leak is when an object lives longer than it's supposed to live. An activity has a life cycle, and if you're holding a reference to activity, even though that activity is destroyed, the instance will stay there. So the resources, all of the allocations, and every other thing will stay there. And doing this one multiple times during the application lifetime will increase the pressure. This is one of the good analogies that I like. Whenever, if you don't start with memory pressure part, no matter what you do, it's not going to affect the rest of the application. And then I personally saw most of the improvements after fixing the memory leaks in the application. Well, we have good tools for this one. First of all, integrate the leak canary for your testing environment. I saw companies and projects disabling that one because it created so much noise. It is not a noise, it is a performance problem. We need to be concise and plan and fix those kind of things before reaching the production. Otherwise, we end up having other bugs that it will be difficult for us to fix. There's profiling in the Android Studio, and the strict mode also could tell you if there are more than one instance of an activity living in the runtime. There's one unannounced, unadvertised library from Leak Canary. It's called Plumper. If you go there, it has like Maven address and everything. You can edit your application. What it does, it has like more than 15 known leaks from different devices and different operating systems. With some help of reflection and with some help of the APIs, it tries to fix those. And for example, if there's a leak of activity context, the Plumper tries to clean that context for you on those old devices where you don't have to create your own fixes. I highly suggest integrating it, and if you're still supporting old devices, I find it very useful, but it's not being promoted well enough. So when you want to do memory optimization, one thing you can do is sharing them with thread pools. Why? We would like to be concise about what we allocate. And in the Android world, creating a thread pool is an expensive operation. Creating a single thread is even an expensive operation. It takes 1 to 3 megabytes. It uses CPU and operating system resources, and it needs to create multiple other connection to the operating system itself. And if you look at your application, you can put a debug pointer to the thread itself and see which libraries are creating. More libraries you integrated, you will notice that there are multiple thread pools in the application staying there in idle state without doing anything and just allocating. These are some of the examples, but based on which frameworks are using, which libraries you're using, the list goes on. So what we did is we start sharing those thread pools between our multi-thread options, RxJava, OKHTTP, and the Coil and our image loading library, as well as Glide and Work Manager also has their own thread pools. What we did, wrapping the coroutine, by wrapping the coroutines dispatcher as executor and passing those additional libraries, we were able to save more than 50 or 50-ish threads at runtime. So that means there will be less idle thread, more allocation spaces for the application. And when app needs to run a context, when it needs to run a runnable or anything, there will be available thread that we don't have to wait for initialization of it. So in general, it will be smoother. There are runtime optimization we get out of the box if we start using the DexGuard and ProGuard and R8. R8 automatically optimize some of the codes that we have. if you look at the compose code, for example, you might think that there could be more efficient codes. But the way that R8 works, it knows some of those inefficiencies and already optimized them. There are optimization for the string builders, there are optimization for the for loops, and there are optimization for enums. I don't know the exact number, but there are good amount of optimization that we get out of those tools when we use them. If you'd like to learn more detail, this is the official documentation, and there are really nice blog posts from Jack Wharton to go deep dive in those topics, explain why those optimization works when we compile the code, and why it's not a good idea to write our code like that, because it will not be maintainable. If you're more curious about it, there will be another talk from Ben Wise today at the Glassroom, and he will talk about more about how to measure the performance and take actions with those kind of improvements. And I'm already mentioned that I suggested using multi-threading solution. We don't want to execute operations on the main thread. That's why we have RxJava. That's why we have async tasks. That's why we have coroutines. What we need to do, figure out those long-run operations and move them to main thread as much as possible. Of those main thread as much as possible. One way you can do is, and this is my preferred way, it might be different for different companies and different things. I like to set which thread or which core the dispatcher needs to be used for a specific operation at the lowest level possible, because that's the time that I'm pretty sure that I'm going to do IO operation or I'm going to do network operation, instead of letting someone else, the higher level, to decide which operator, which dispatcher or scheduler they need to use. I like to set this one at the low level. Why? Because when someone else uses my code, they will not have any threading issues, they will not have any worry about which scheduler they need to use, they can just freely call the suspend functions. You might think, yes, we start using compose, it's inefficient, we are getting some slowness out of it. We even did an experiment in our company, and one of the product found that using compose increased the delivery time 5 seconds. Right, so then we did the investigation. It turned out there were other crashes. The reality is not that. And then we did more investigation. We found out it mostly affects the slow rendering. It also affects the first pixel. But optimizing the composition is not something that is going to give you the most of the benefit. What you can do is only focus on the correctness of the UI. Don't apply the best practices. Don't try to reinvent the wheel. And in the end, with every new update of the compose, with every new baseline release, with every new implementation that you have, you're going to get some sort of performance improvement. But that's not the only tool that we have. One of the things that we notice is that we need to utilize the donut hole approach as much as possible. Why? Because lambdas are special in compose. They capture the values, and they only get invoked when that value is changed. And if that value is only used in the lambda, that means rest of the composition will not occur. I would like to show an example for that one. Let's say you want to rotate an icon and loading dialog or anything like that. You will have an infinite animation that goes all and on. And when you set the rotate, that will trigger whole compose to recompose. Why? Because the angle value is directly being used inside the composable. But in the second example, which is the good example, angle is only used inside the lambda, and that lambda is specifically only used in the placement of the composable. That means compose will understand to skip re-invoking the icon, re-invoking the image vector and everything, and just continue to rotate the already driven screen. Already driven images. This is more about rendering the first pixel. So every compose release brings new improvements to first pixel rendering. I highly suggest to keep your compose versions up to date, and they're doing a fantastic job about it, and you will notice improvements over time when you do updates. But one other thing that you can do and start doing today without waiting them to release more updates is using efficient resources. One thing that we notice is showing icons and showing vector drawbles are expensive operation because we want to set them at the beginning of the life cycle of an activity fragment or compose. That means system needs to load them. And if you have multiple of those and big icons, that's going to be difficult. WebP is an efficient way of storing those images instead of PNGs. And Android has optimized runtime for drawing those. Android Studio can help you to convert all of your PNGs to the WebP, and you can start having smaller application footprint, also as well as the faster runtime. Well, I say you have vector drawbles, which is more efficient, like which is supposed to be more efficient way of storing scalable images, but it turns out there is an initialization cost of it because it is all math, and system needs to understand which line goes to there, which angle it needs to draw. And it's not a simple task to do. This is one of the illustrations that we had in the application. This guy is doing heavy lifting, and this is how it does. So this definition goes and goes and goes. That means when we want to do the first rendering, system needs to read this XML, understand which line goes which direction, and creates a SVG, then renders. For this one, the best thing you can do, best thing you can do is that you can talk with your designer, ask them to create smaller illustrations, or ask them to create WebP images instead of, like PNG images instead of vector drawbles like this one. That will immediately solve some of the problems. And you can already figure it out, do you have this kind of problem by doing CPU profiling? Because you will immediately see that 50 milliseconds to 100 milliseconds of load time for a single icon. And if you have tens of icons, it's the invitation for frozen frame. But other important topic for first pixel is the dependency injection. Before even deciding which logic needs to be rendered on the screen, activity or fragment needs to come alive, like it needs to start running. And the first thing that we all do most of the time is dependency injection. It is there to help us, it is there to provide instance so we can run our application. Well, what happens? Our instances are slow. And what happens if it takes a lot of time? One of the things that we figured out, there are things that we are not happy to inject in our dependency graph. But since they're there, we need to figure out how to optimize them. We added some tracking to our OKHTTP generation and encrypted shared preference generation. And it turns out that OKHTTP could take up to 100 milliseconds. And if it is not a singleton object, that means every time there's a new screen or there's a new object, there's a new retrofit service, it was generated again and consumed this 100 milliseconds again. And the encrypted preference is similar. Just because it used the encryption on the device, it is able to take up to 500 milliseconds. If you have more than one encrypted shared preference, which can happen if you are using other libraries, in our experience, we now have 4 encrypted shared preferences, and 2 of them are not coming from our code base. So the other services that we use already utilize this kind of things, but that affects the application startup time. We are working with them. We also improved our APIs, and this was the result. Like we immediately, the moment we were able to take this injection and creation from the main thread to the background thread, we were able to see immediate result. And this is how you can do. You can already start checking if your injections are happening in the main thread. You can check the looper inside your providers or binders. Because if the looper is not the main thread, is the main thread, means that you're doing an expensive operation. I highly suggest adding a trace there. You can use other tools, or you can use normal logging for your measurements to verify. But this basic log was very helpful. You don't have to start with the exception, obviously. You can just start with the logging. But when you fix all of the problem, I highly suggest adding an exception there to make sure that no one injects this dependency into background thread. And you can also use dagger.lazy or inject.provider to get the provider itself, but only call it and create it in the background when it's necessary. For the first pixel, Play Store also helps you a lot. without even knowing, without even integrating it, when our applications run on the runtime, just-in-time compilation creates some compiled version of our code, and there's also ahead-of-time compilation that prepares and warms up our application to run faster. Those things are shared across devices with the help of Play Store. Play Store gets this profiling data, which classes are being loaded during the startup, and share this one with the rest of the world. But this information is delayed a couple of days, and it's not guaranteed that every device will get it. Older version of devices will not get it for sure. But what you can do, starting from today, start using the baseline profile. No, there are lots of advertisement about it. We were also skeptical about it, but we are doing release every week. That means once a week, people could experience this slow startup. And if it is happening during their shift, during their work, it can affect them. Instead of creating these edge cases, we decided to start using it. And it was fairly simple to integrate. There will be office hours to integrate baseline if you have questions, but it immediately gives like 20%, 30% in certain cases on certain devices. Thing is, libraries are also already utilizing it. Compose and some other Jetpack libraries already comes with their own baseline to be able to give you the performance that you need. What you can do is adding your own use cases like login flow, your notifications, your deep links, to make sure that your application is ready to run whenever it's ready. But I would like to show you some real example. So I tried some time to create a fresh application where I can upload and demonstrate, hey, this cause of ANR, this cause of frozen frame. I'm getting there, but I wasn't able to create an ANR on the fresh application without any external dependencies. There are ways to do it with the services, there are ways to do it with the process. I was able to do that one, but on the runtime with the injection and other stuff, wasn't able to create the ANR. So that's why I would like to focus on the vector durable and how you can improve that one. And if you have tens of this one, this sad guy with no internet connection, which is unrealistic, but we all have back arrow, we all have loading dialogues, we all have different sort of icons on the screen, and if you have button navigation, you might have more. Based on the details of this one, your application will start slower. And in this example, this particular one took 78 milliseconds to initialize on a release build, on a Samsung, last year's Samsung phone with R8. So with all of the optimizations that we get from our tooling, there's still things that we can improve. One thing is that by the way, it looks like this when you go, and we are discussing with our designer to convert this one to another illustration format that will be more useful. But until then, we are using our image loading library to be able to asynchronously load this kind of big images. So if you know that you already have this kind of inefficient images, what you can do, you can use async image from Coil or Glide or any other async image provider and just load your resources with the same image library you love and you use for the network operations. They most of the time support loading resources, like loading images from the resources, and they will load it in the background thread. That means your application will be able to show at least the first pixel. A couple of milliseconds later, 10, 20 milliseconds later, the image will come. That means less frozen frame, less ANRs, and better performance. Here, I was missing this one a couple of slides early. And when you investigate the ANR problem, I know it's difficult. Most of the time, stack trace doesn't tell us anything. And there is a reason for it, because the moment runtime decides that there's an ANR, it wants to take a stack trace capture, so we all know where the issue is. But up until Android 14, it was very slow. Sometimes 300 milliseconds, sometimes seconds to capture that particular thing. That means the moment the device had the ANR is not the same as that we get the capture. I highly suggest when you're looking at the ANRs, filter for Android 14, because they reduced the ANR capturing to 30 milliseconds to 50 milliseconds. That means you will get more accurate stack trace about what you need to optimize. That's not ideal because runtime is also optimized in Android 14. There will be less ANR, but at least it might give you some indication where you can start to fix and point out the inefficiencies. But the real story is this one. When you see a stack trace, it's not necessarily that application stuck there. It could be that unlucky position in your application runtime that gets triggered all the time. So there could be different inefficiencies in the code, and this is the example that I'm trying to set here. I couldn't find a good example from our application, but this is a manual one I created. Means that there could be multiple other slow operations, but the last one will get the stack trace capture. So in this case, you need to figure out the flow itself rather than focusing on the stack trace. When you see a parsing, like when you see a unexplainable ANR, always consider how my code reaches here and if it stays on the main thread all the time. If it stays on the main thread, guarantee you there could be like injection issues, there could be inefficient parsing on the main thread. Maybe someone allowed doing database operation on main thread, and those kind of things affect each other, accumulate, and trigger the ANR. One thing we all can do is measuring as much as we can, but we always work with the debug application. That will be inefficient for sure. Why? There's debuggable code that is being injected. It's not optimized. So it is suggested that you need to do your profiling on a release build as much as possible. We cannot do direct profiling on the release build, so you can create a different variant that is debuggable, not debuggable, that is profilable. There are ways to do it, and there are good documentation explains how do you do it, but the idea is there will be more than 2 times difference when you do profiling on the debuggable application. But when we would like to collect data from production, things get different because it needs to be sampled. Why? Collecting those information also could be costly on the devices. And if multiple things are being collected at the same time, again, it will allocate memory, it will use CPU, and it will also use network. That's why we would like to do some sampling. There are tools that can help us for this one. And there are tools that help us to collect real data from the devices. Perfetto and the systrace are tools that gives us detailed information about what's happening on the system. And if you like to go deep dive, which functions are, which methods are being called, or like which allocations are being done, you can use Android Studio's profiling options for the CPU and allocation. Recently, Layout Inspector and Debugger got amazing capabilities for compose. When you use Layout Inspector, now it shows the composition count of a composable. So if there's an inefficient composition, you can open the Layout Inspector. This option is still behind a checkbox, but when you enable it, it gives you the amount of recomposition happening on the device in real time. So you can prioritize which part of the application you would like to work on first. And the debugger as well. When you put the debugger inside the composable, it now tells you which parameter was unstable or which parameter has changed and triggered this composition. When you're working on those kind of UI issues, you might want to look at debugger and the layout inspector. So instead of looking at the plain code, just trying to understand if the composable is in line, is the composable skippable or parameter stable, they give you more clear information about what's happening on the runtime. Also, those options are just for your controlled device, controlled environment. What we need is the real data. We can use Firebase Performance or any other equivalent performance metric tool. You can integrate your own reporting tool with the help of Jenkstat. It gives you the detail about what's happening on the device with the frozen frame and the slow rendering. So you can send whatever reporting tool you want to send. For the memory leaks, you can I highly suggest collecting memory leaks and the strict mode violation from your test users. We enabled this reporting for leak carry and the strict mode. Before going there, if you'd like to learn more about those, there are 2 great talks. I'm also very excited to listen to them. And there will be deep dive on the Perfetto. That's the reason why I'm not going into details. And effective app monitoring in the production, which I'm really curious of. I would like to learn if it is similar to what we're doing or the different. I highly suggest going and listening to them. But if you like, take a picture. Good. So, like I mentioned, collect as much as data possible from your test user. We enable the strict mode with integration with the Firebase, crash statistics. We were able to collect inefficiencies that's happening on the devices of our test users, and we have a lot of test users. This is how you enable the strict mode, and if you look at it, you're able to set your penalty listener. You don't have to call, you don't have to ask for the death penalty, you don't have to ask for the basic logging. You can say that, I would like to get notified about it, and I want to send this one to my favorite reporting tool with the options that I have. So when you do this, you also have opportunity to see what your application is doing in the wild. And we figured out a lot of cases about the process restart and services that we were not able to easily reproduce under our testing conditions. This gives us lots of confidence after we fixed the issue, because we were able to verify before even releasing the application and just testing in a bunch of devices and see that, okay, we don't get the strict mode anymore on different variants of the devices. Let's say you did everything you can, runtime optimization, move all of your code to the background, all of your images are optimized, you did your profiling and found out inefficient dependency injection. That's just the one part of the performance. Things that we move to the background still need to execute with the same amount of time. So try to utilize those profiling tools to find what you can cache on the device, what you can improve on the device. We figured out a couple of HTTP interceptors were using some data to be able to create a header. So what happened is, almost all of the time they were running 10, 15 milliseconds, 20 milliseconds. That means every network operation is actually was slower than what we actually expected. The reality could be different than what our expectations, so that's why we always need to measure. Before and after, we did an improvement. Okay, the retro. So 10 years ago, like I mentioned, I was responsible of a chapter in an Android book. And in the 10 years, lots of things changed, but we're still optimizing. We got much faster devices. The technology evolved, and our software is also evolved. We are integrating more features, more things, but we still need to do some optimization, and it's our responsibility to do so. And 10 years ago, 10 years ago, my suggestion was using the view hierarchy and the view stubs. If you are using XML-based view, it's still viable, but in Compose, it's much easier. With an if check, you get your basic view stub logic. We had list view folder. Then 6 years ago, we got the recycle view, and now we have lazy column. If performance is really important for you, you might want to stay at the recycle view with your old implementation before moving everything to lazy column, because there are still inefficiencies. Well, like I mentioned, with every release, it's getting faster and faster, and we still have a long way to go to get the same performance as the recycle view. We had memory leaks 10 years ago. We still have memory leaks. I'm a little bit sad about it, to be honest. And luckily, we have a tool called memory leak to find those, because not all of the platform have something similar for their use cases. And I also remember the times that we had to dig and read the code, do the code review and audit, and find those issues by just reading the code. Running in the background was option with the async task. Luckily, it's deprecated. Used coroutines and be lifecycle aware. And we still have things to optimize. They're just different. I really wish you to have this kind of chart in your next release. And if you do, if you apply any of the suggestions and see improvement, feel free to tag me. Or if you don't see it, I will be really curious to talk about it. But thank you for coming today.